Hey everybody, this is the video covering rational graph transformations. Up at the top, we just have a section up here talking about transformations in general. This equation does look slightly different than the ones we've covered previously, but we have done transformations for absolute value graphs, quadratic graphs, and cubic graphs this year so far. All of those transformations had A, H, and K exactly in the same iteration they're in right now. The other ones also had B, but we're not going to deal with B for rationals, just A, H, and K. I have our little summary up here for you. And then here is a picture of the parent function. We're going to label that parent function. And this is 1 over x. You can see it right there. As you can see, compared to our equation here for the parent function, a is 1. You can see it right there. H is not here, so it's really plus 0. And K is not here, so it's also plus 0. So right now, H and K are both 0 for the parent function. And those are going to help us figure out our vertical and our horizontal asymptotes. So I'm going to highlight those on the graph here. Here's our vertical asymptote. It's the one that looks like a vertical line. Our graph is going to approach it and not cross, obviously. And it is at x equals 0. Because it is a vertical line, it's going to be x equals. And then it crosses right here through the origin. For our horizontal asymptote, I'll use a different color for that one. That is right here. There we go. And our horizontal asymptote is going to be y equals, and this one is also, you can see it crosses right here at 0. Perfect. And then up here, we're just going to mark which h or k gives us which. So h decides horizontal transformations, and it will give us our vertical asymptote because that impacts where we are horizontally. So h gives us the vertical asymptote. Let's squeeze that right here. And then k gives us the horizontal asymptote because k deals with vertical transformations. So that changes where we are compared to the axis, specifically to the y-axis. Okay, there we go. Perfect. Now what we're going to do is just go over the boxes down here at the bottom. I'm going to start just with k. And k says the value of k can help you figure out the vertical translation of the graph. And that one, there we go. Sorry. Okay. And that one is right here at the bottom in this little box. Our first one shown, the dotted line, is just 1 over x. That's our parent function. As we already talked about, k back here is 0 because there's no number back there. And that would also make our horizontal asymptote at 0. I'm going to highlight that. It'll be right here. And the easiest way to see where that is just look where the graph flattens out left and right. It's going to flatten out at the same number, and that number is the horizontal asymptote. Let's look at the next one. This next one is 1 over x plus 3. That is the equation that made this graph here, the solid line. And we flatten out, we put our k first. Our k is 3. So our horizontal asymptote is y equals 3 because we flatten out at 3. So right here, that's where our graph goes flat, left to right. So for this one, it moved up. You can see we were here, and now we're up here, moved up 3 spots. So when our k increased from 0 to 3, we moved up 3. So for k increase, we're going to say move up. But our last graph, you can see that one is scooched down. Go, it's right here. And the equation for this one is 1 over x minus 3. You can see our k, that number in the back that's not in the fraction, is -3. And you can see our graph goes flat at y equals -3. So for this one, when k went from 0 to -3, it scooted down 3 spots. So as k decreases, we move down. Good. Now let's look at our horizontal translation. I'm going to skip different color for that. Well, our horizontal translation, is going to be h. You can see the pictures here at the bottom. Just a reminder, when we're dealing with h is on the inside of the fraction. It's going to be on the denominator. Because it's inside the fraction or on the fraction, we are going to do the opposite of what normally happens, just like we have been doing for all of our other transformations as well. So here is our parent function.
Oops, sorry. Look at me having the wrong thing. Here's our parent function right there, 1 over x. At the bottom, we just have an x. That's really x plus 0 at the bottom there. And that means that our h is 0. So our vertical asymptote is x equals 0. And for this one, when you're looking for the vertical asymptote, you're just going to look where it goes flat up and down instead of left and right. And that's going to give you the vertical asymptote. Let's look at this next one. So this one right here is going to be the equation 1 over x minus 3. And you can see here our h appears to be negative 3, but because it's inside, it's going to be the opposite sign. It's actually going to be positive 3, which means our vertical asymptote is going to be x equals positive 3. I'm going to highlight it right here, right there. So you can see this one moved to the right, right? It went this way. And it moved to the right when it appeared to be negative. So when h appears negative, so appears negative h, we go right. And then we'll do the same thing for the other one. This one is 1 over x plus 3. And you can see here, right there is our vertical asymptote. So it says 1 over x plus 3. That means h is going to be negative 3. It's going to be the opposite of what it appears because it's on the inside of the fraction. And that means our vertical asymptote is x equals negative 3. You can see it right here. And we went this way this time, to the left. So we scooted left when we appear to be positive. Move left. And then I forgot to draw our arrows, sorry. The movement arrows for these ones, these were up and down. Good, and then our last one we're dealing with is A. A is in the numerator of our function, and A is going to impact the dilation as well as the reflection. So looking at the first box, this is the bottom left. It says the value of A can help you figure out the vertical reflection of the graph over the x-axis. Vertical reflection. I'm just going to hide over the x-axis. This is the one that spins like a wheel. Remember, we always say wheel or tornado. This one spins like a wheel. And this is our original function, 1 over x. That's our parent function. A is 1. And you can see that it has a branch in the top right and a branch in the bottom left. With the A being positive or negative, that's going to be the way we figure out what the right side looks like. So here, the right side is above the horizontal asymptote. Above HA on right. And that's similar to how A impacts our N behavior for all of our other functions as well. You learn about that a lot more in pre-cal next year. And then when we have negative A, I'm going to draw our rotation arrows. See, it's going to rotate from up here to down there, and then from down here to up there. See, it's rotating like a wheel. This is a vertical reflection. And as you can see, once it's reflected, it is now below the horizontal asymptote on the right side. Below HA on right. And this is when you have negative 1 over x, so when A is negative 1. Good. Our last one is vertical dilation. These are going to be the same words we've used the whole time. They're just going to look a little bit different for rational functions. So this first one is 1 over x again. 1 over x. And that's when A is 1. Obviously, it's the number at the top of the fraction or in the numerator. This second graph is a representation of when A is 2, so 2 over x. And you can see our graph is a little bit wider, but it's not going to be said in a wide way because it goes all the way over here on both sides no matter what. That's how wide it is no matter what. It's this space that's going to change. See, now it's farther away right here from the origin. And that is being stretched up and down, right? It was here. If it's pulled up like this and pulled down like that, that would stretch it to look how it is right now. So when our A increases from 1 to 2, we see a vertical stretch. And this is what it's been called the whole time. So this one, we stretch up and down. We pull up and down like that. So we're not just moving up or down. We are pulling the graph to make it taller, basically. And then our last one here, this is when we have a 1/2, so 0.5 over x. You can see this one is closer to the origin. And this one is when we compress down. So if a is 0.5, this is when a decreases. You can see it's closer to the axis, right? It was here and now it's there. It was here and now it's there. And that's because you're pushing down. If you push down on this graph and push up on this side, it'll get squattier like that. So I'm going to draw the arrows there. So here are the compression arrows. When we compress both sides, we're not moving up and down, we're squishing it basically. Vertical compress. Okay, I'm gonna back up so you can see the whole thing. Please make sure before we go on that you've written all of your movement arrows. The movement arrows are really important to know what's going on. These ones. This part, make sure you've drawn these. And then what I want you to do is go ahead and pause and see if you can fill in the summary boxes on your own and then come back when you're ready. Okay, here is our boxes filled in. So on the A box, we just wrote down how it's above the axis or above the horizontal asymptote actually for positive A and below for negative A on the right side. And then a vertical reflection. Increasing and decreasing A would stretch or compress. Moving our H would be left or right, and then K would be up or down. Perfect. Okay, let's look at the next page here, our graphs. We can graph them. So what we're going to do on these ones, the easiest way to do it, at least in my opinion, is to graph the vertical and horizontal asymptotes first, and then deal with actually finding the points on the graph. For every graph, I went ahead and already put on there for you 1 over x, which is our parent function, which has a vertical and horizontal asymptote of 0. And then we're just going to look at the one it gave us. So this one, it says graph g of x equals 1 over x plus 2 on number 1. Our a is 1. Our h is -2. Remember, it appears to be positive 2, but it's the opposite. And then our k is not there. So k is 0 because it would be plus 0 at the end. So I'm going to write down what we got here, vertical asymptote and horizontal asymptote. I'm just going to look over here on our last page and make sure I know which one gives me which. So it says right here, h gives us the vertical asymptote and k gives us the horizontal asymptote. I'm going to write that up at the top. Okay, there. Okay, so our vertical asymptote, we get that from h. H is -2, so x equals -2. And then horizontal asymptote we get from k. K is 0, so y equals 0. And then I'm just going to graph those directly onto the graph. So -2 is our vertical, and then 0 is our horizontal. Good. Now, next, what we're going to do is graph it in the calculator and look for an x or a y intercept. And then we'll also use the graph from the calculator to figure out, oh, my graph is funky, to figure out, there we go, what our transformations were. So we're just doing 1 over x was our original function. I'm just going to make that a black dotted line so it looks like it does on my graph. So this is what we already have. And now we're going to graph g of x, which is 1 over x plus 2. So here's right there. So you can see pretty easily what happened here. You can see it just scooted to the left 2 spots, right? It did go up and down at 0. Now it goes up and down at -2. It doesn't look any wider or any skinnier. It doesn't look like it's been compressed or stretched. And it has not moved up or down because it still goes flat at the origin. But it did definitely move. So shift left 2. That would be the transformations that happened. That's the only transformation that happened. Now let's go ahead and see if we can graph this. We don't have an x-intercept. We do have a y-intercept. It is right there at 0, 0.5. So I'm going to put a dot at 0.5 right there. And then to get the rest of the dots, I'm just going to open up a table. And it's always going to give me -2 to +2, and then I'll see if there's anything else I need past that. So -2 is undefined. That's our vertical asymptote. -1 is at +1. 0.5 we already got. 1 comma 0.3, that's going to be really close to the line. And then 2 comma 2.25, that's going to be even closer to the line. So that was what that looks like right there. And then you can see our graph is going to swoop up and swoop to the right. So I'm just going to draw the line really close to my asymptote on both sides. There we go. So there is the right branch. Now the left branch, I don't have any dots on yet because it doesn't give me anything past -2. So I'm going to go down here and click on the next open box and type in -3, -4. I'm just going to look for a couple, and -5. See, those are getting really close to the horizontal asymptote at 0. So -3 is at -1. -4 is at -0.5. And then -5 is at -0.3. So let's look right there. Remember, it's going to swoop really close to both asymptotes. It's going to go flat like that, go through our dots, and then get really close to this vertical one. And there we go. Now you can see we now match the picture. And that's how you do it. That's how you do all of them. So let's try another one together, and then you can try on your own. Let's do number 3 together. So number 3 says 2 over x minus 2. First, I'm just going to mark everything. So a is 2. It was 1, so there's going to be a change in a. H appears to be negative, so it's +2. And then we don't have a k, so k is 0. Remember, I'm going to get my vertical and my horizontal asymptote first. So vertical asymptote I get from H. H is +2, so x equals 2. Horizontal asymptote I'm going to get from k. K is 0, so y equals 0. And then I'll just graph those. So here's y equals 0. And then x equals +2 be right here. Good. Now remember, I'm going to graph in my calculator. I'm going to keep the 1 over x there just because that's going to be what I'm going to compare to every time. My new function is 2 over x minus 2. And it gave me a black one. I'm going to change the color just so it's a little easier to see. So here's our new graph. You can see pretty easily it definitely scooted to the right 2 spots. So shift right 2. It does also look like it's kind of at a different angle, right? It looks a little different on the rounded part, and that would be A. And it is different for A, right? A was 1, and now it's 2. So looking over at our summary here, A went from 1 to 2, so A increased, so it was a vertical stretch. So here is our 2 transformations. And then all that's left is just to graph it on my paper. I'm going to look for a horizontal a x-intercept and a y-intercept. There is no x-intercept because we have a horizontal asymptote at 0, so it's never going to cross the axis. You can see that on your paper or on your graph. But our y-intercept is -1. And then to get the rest of the dots, I'm just going to go over here, push the settings button, and push the table, where it's always going to give me -2 to +2. And then I'll add on from there. So -2 is at -0.5. -1 is at -0.66. 0, -1, we already got that. 1, -2. And then 2 is undefined. So you can see it's going to go like this. It's always going to go really close to both asymptotes. And it's going to look like that. And then we don't have anything for the right branch yet because it starts at 3. So I'm just going to come down here. I'm going to push 3. And I'm just going to push a couple more to see where it goes. So 3 is at 2. 4 is at 1. 5 is at 0.66. 6 is at 0.5. And remember, it's going to swoop up and swoop down. So swoop really close here, curve there, and then go right there. And there we go. So now you can see compared to the picture that it looks the same. And that's how you do it. Good. So go ahead and see if you can do number 2 and number 4. You do, and you do on number 4 as well. Just so you know, on number 4, they did put K in the front. This is still K. So K is still +1 in the front. It's the same thing as having it in the back. So go ahead and pause, try number 2 and number 4, and then come back when you're ready. Okay, here are the 2 that we just did. So we did 2 and 4 just a second ago. Here is number 2.
Number two, the new graph was 1 over x minus 4. Our a was still 1. Our h was still 0 because there wasn't a 0 or a number down there. And then our k was minus 4 or negative 4. So you can see our graph moved down 4 spots. So the transformations was just shifting down 4. Remember, the first thing I'm going to do is graph my intercepts. So I graphed negative 4, y equals negative 4, and x equals 0. And I got those from h and k. I wrote over here that k gives us the horizontal asymptote and h gives us the vertical asymptote. And then remember what I'm going to do after I graph my asymptotes is I'm going to put this in the calculator and I'm going to look at the intercepts. And I got an intercept on just the x for this one. And then I'm just going to look at the dots and I'm just going to graph the dots. And that's what I did. And then number 4, here's number 4. We had k was 1. It was in the front this time, but it's still the same thing, still k. It's the only number that's not in our fraction. A was 1, and then h was negative 3. Remember, it's the opposite of what it appears. It appears to be positive 3, so it is negative 3. So that means our vertical asymptote was at x equals negative 3, and our horizontal asymptote was at y equals 1. So I graphed those first. Then I graphed it in Desmos. My intercepts, I had both x and y. X was negative 4, y was 1.333. I just clicked on those. And then I went to the table and I graphed the other points I could find. Just a reminder, when you're graphing your points, sometimes you're just going to have like 2 points right here and that's it. But you do know it's always going to go really close to those asymptotes. It's just not going to actually cross over them. And then here are the transformations that I wrote down for my graph. And here's my graph. Perfect. We saved the last 2. We'll do these together as a warm-up. So this is all that we did in class. Hope this helps. Bye.